Hi guys, welcome back to my mathematics tutorial. My name is Peter C. Duckworth Jr., your math tutor. I'm also an instructor of mathematics at the University of Liberia. In today's lesson, I will be teaching finding derivatives of trigonometric function. But to start with, we will be deriving the derivatives of the 6 trigonometric functions. Now, in previous lesson, under finding derivatives using the first principle of derivative, we did prove all of the derivatives of the trigonometric function. So we found the derivative of sine of x, cos of x, tangent of x, cosecant of x, secant of x, and cotangent of x using the first principle of derivative. So you can just watch the previous videos. But in this case now, we want to use the method of, the properties of derivatives, that is the methods of differentiation using the product rule, using the quotient rule to find the derivatives of, to derive the derivatives of these trigonometric functions. So basically what we want to use is, we want to use the first two main derivatives of trigonometric functions. That is the derivative of a sine function and the derivative of a cosine function. So all of the trigonometric functions basically derived from the sine and all the cosine functions. So if you know the derivative of sine and cosine function, you can be able to derive the derivative of the tangent function, the cosecant function, the secant function, and the cotangent function. The same with the trigonometric identities. When you know the sine and the cosine identities, you can be able to derive many other identities for tangent, cotangent, cosecant, and secant. So that's exactly what we want to do. So in previous lesson, we said that given a function y equals to sine of x, the derivative, assuming that this is just u now, wherein u is differentiable, the derivative of this y, that is y prime, is just equal to cos of u times u prime. That is, you differentiate sine of a particular angle called u, and you also differentiate the angle separately. So there's the basic derivative of sine function. Also, the derivative of cosine function given y is equals to cos of u. We know that y prime gives us negative sine of u times the derivative of this u, which is u prime. So these two derivatives, we derive them from the first principle of derivative, that is f prime of x is equals to the limit of f of x plus h minus f of x all over h as h is approaching 0. So we derived these identities from this particular formula in previous lesson. Now, let's use these two derivatives to derive the rest of the other derivatives of the trigonometric function. Now, the first one is the tangent of u, for instance. Now, we know that tangent has a quotient identity that relates to sine and cosine. That is, tangent of u is equals to sine of u all over cosine of u. So we know that tangent of u is equal to sine of u all over cosine of u. So with this quotient identity of tangent, we can now be able to find the derivative of tangent using the quotient rule, or we can send this cos of u in the numerator and use the product rule. So if you just replace the derivative of this sine of u, right? Let's say sine of u now, if you find its derivative, it gives you cos of u times u prime. And then this gives you sine of u. But you are not going to take this and put it there and take this and put it there. No. We want to use the quotient rule to find the derivative of tangent of u. So that's exactly what we want to do. So assuming that this function was y is equal to tangent of u. So tangent of u now has been rewritten in the form of sine of u all over cos of u. That is y equals to sine of u all over cos of u. So let's now find its derivative using the quotient rule. Remember the quotient rule says if you have u over v, y prime is equal to v u prime minus u v prime all over v squared. That is, if you have a function in the numerator and a function in the denominator, you can hold the denominator's function first and you differentiate the numerator and then you get u prime. So it doesn't only have to be u prime, it could be a function like we have here sine of u. So you differentiate sine of u and minus, you hold the numerator now, which is u, and you differentiate the denominator. So this is exactly what we also derived in our previous lesson. So let's use this property now, or this particular derivative formula now to solve this problem. So we have y prime equals, so this represents our v, and this represents our u. So we hold our v, so it's cos of u, times we differentiate the sine of u. So the derivative of sine of u is just cos of u. Now, if you differentiate u, you just get 1. Minus, we hold the numerator now, sine of u, and differentiate cos of u. So the derivative of cos of u, we say, is negative sine of u. So it's negative sine of u all over this cos of u all square. Or let's write it like this. Okay. Now we simplify now. So y prime equals cos of u times cos of u is cos square u. Now this negative times this negative is positive. Sine of u times sine of u is sine square u all over cos square u. Now whenever you are dealing with trigonometric, bear in mind that you must have an understanding, you must have vast understanding as it relates to the trigonometric identities. That is the quotient identities, the reciprocal identities, the Pythagorean identities, the sum to difference, sum to product, the sum rules, the difference formulas. You have to know all of them. The double angles, the half angles, you have to get them at your fingertip. Because if you don't, derivative of trigonometric function will give you tough times. Because sometimes to differentiate might be easier, but to simplify might be a problem. They might give you a problem with a particular answer attached. To get that answer now, you have to simplify that trigonometric function further. So you need to practice the identities. We have videos for them. Check our playlist. We have videos on trigonometric identities. You just watch them and you have a better understanding of these identities. In fact, we derived all of them. So now, in the numerator, we have an identity called the Pythagorean identity, which is one of the fundamental identities within a trigonometric function. And it was derived from the equation of a cycle with the radius at its center. So it is cos of u. So the u now, this angle can be just any variable, x, y, u, and so forth. So cos square u plus sine square u is equals to 1. So know that this identity is a Pythagorean identity. From this identity, you can derive several other identities. For instance, you can solve for cos square u. So cos square u is equals to 1. You send this one across, it becomes sine square u. You are plotting one identity here as well. So you can solve for several other identities from this particular identity. So now the numerator now is just 1 divided by cos square u. But this this cos square u can be rewritten as cos of u times cos of u, because we know that cos of u times cos of u is equal to cos square u. Another identity that we know is that secant of u, for instance, is equal to 1 over cos of u. So we call this identity the reciprocal identities. This is a reciprocal identity for the trigonometric function. So secant of u is equal to 1 over cos of u. So 1 over cos of u is secant times 1 over cos of u is also secant. So it means y prime now will be secant of u times secant of u, which will now give us secant square u. So this implies that the derivative of tangent of u is equal to secant square u. So we're just going to put the summary right here. So let's put the summary right here. So the first one, so we say d by dx of sine of u is just equal to, okay, let's use x so it doesn't confuse you, right? So d by dx, that is the derivative of sine of x, is equal to cos of x times x prime, that is times the derivative of this x. And then d by dx of cos of x is equal to minus sine of x times x prime. Oh, then the next one, d by dx of tangent of x is equals to secant square x times x prime. So this implies that whenever you differentiate a trig function, you must also differentiate the angle. So be it x, u, or whatever that is here that representing the angle, it must be differentiated. So we've got the first three. Now let's move on to the next one. So the next one is y equals to cosecant CSC of u, for instance. So if you have this, you can rewrite this CSC in terms of a reciprocal identity. That is, CSC is equal to 1 over sine of u. So then we use the quotient method. So y prime equals, we hold the denominator, sine of u, and we differentiate the numerator, it gives us 0. Minus, we hold the numerator 1, and differentiate sine of u, it gives us cos of u. All divided by this sine of u, all square. So this cancel, so we'll just be left with cos of u all over sine square u, because this sine of u times sine of u is sine square u. So we can like expand this denominator, that is cos of u divided by sine of u times sine of u. So we just put 1 right here. Now y prime equals, so cos of u, cos over sine. So we know that from the quotient identity, cot of u is equals to cos of u all over sine of u. So this is just equal to cot of u, cot, and this is just equals to cosecant. So this is cosecant, which is, so the first one is cot of u times cosecant of u, or y prime is equals cosecant of u times cot of u, whatever the case might be. It's multiplication. So this is the derivative of finding, this is the derivative for cosecant, that is CSC of u. This is the derivative. So we have d bar dx of CSC of x is just equal to, okay, so there's a negative sign right here, right? We did not include a negative sign. So there's a negative sign. This negative sign affects every term. So this final answer must be negative. So now this is negative cosecant of u cotangent of u times u prime. Or since we're just using x, we have x, and we have x prime. So we'll do the next one. So we have 4, so remaining 2. So we say y equals to secant or sec of u. So what is sec of u? Sec of u, its reciprocal identity is 1 over cos. So 1 over cos is sec. So to differentiate, we use the quotient rule again. We hold the denominator, cos of u, and we differentiate 1, we get 0, minus, we hold the numerator, which is 1, and we differentiate cos of u, we get minus sine of u, all divided by this cos of u, all squared. So y prime now equals, this one cancel, negative times negative is positive, so it's sine of u divided by cos of u, all squared. So like in the previous problem, we can expand this denominator. So we will have sine of u all over cos of u times 1 all over cos of u. So what do we know? We know that sine of u all over cos of u, from the beginning we said there's a quotient identity. Sine of u over cos of u is equal to tangent of u. So this is tangent of u. And then 1 over cos now is secant of u. Or you can rewrite it as secant of u tangent of u. So the derivative now of secant of u is equal to secant of u tangent of u. So d bar dx of sec of x is just equal to sec of x times tangent of x times x prime. That is, this is the derivative, then you must differentiate the angle, which is x. So if the angle is u, it's going to be u prime as well. So we'll do the last trigonometric function. And then in the next lesson, we're going to solve a lot of problems, some challenging one as well, on how to find the derivative of trigonometric functions. So the next one is y equals cot of u. So we know that cot is also cos of u all over sine of u, according to the quotient identity. So it's cos of u divided by sine of u. So from here now we can find its derivative. So y prime equals, we hold the denominator, sine of u, and we differentiate the numerator. The derivative of cos is negative sine of u, minus, we hold the numerator now, which is cos of u, and we differentiate the denominator, which is sine of u. It gives us cos of u, all divided by this denominator, which is now sine of u, raise it to the second power. So y prime now gives us, so sine of u times negative sine of u is negative sine square u. negative cos of u times cos of u is negative cos square u all over sine of u all square. Now, we told you from the beginning that there's an identity called the Pythagorean identity, that is cos square u plus sine square u is just equal to 1. So since this is positive and this is positive, we can factor out this negative by saying negative comes outside sine square u plus cos square u divided by sine square u. Now, mind you, cos square u plus sine square u is the same as sine square u plus cos square u because it's addition. So either of them can come first. So now in this, we have 1. This entire thing is just 1. So y prime now becomes 1 all over sine square u. Again, we can expand the denominator. So it will be 1 over sine of u times 1 over sine of u. So 1 over sine of u. 1 over sine of u, there's an identity called the reciprocal identity again. That is CSC of u is equal to 1 over sine of u. So 1 over sine of u is CSC of u times CSC of u. So CSC times CSC is CSC square u. So the derivative now of cot of u is just equals to negative CSC square u. So d by dx of cot of u or cot of x is equals to negative CSC square x times the derivative of the angle x prime. So as it relates to the sign, you know that the sign is alternating positive, negative, positive, negative, positive, negative for the trigonometric identities, the derivative of the trigonometric functions. So these are the derivatives of the 6 trigonometric functions. So we're going to use these derivatives in our next lesson to solve more problems that relates to finding derivatives of trigonometric functions. So we're going to solve some simple problems, and then we'll move on to solving some complicated problems. So see you in our next lesson. Please don't forget to subscribe, like the video. You can share the video with your colleagues or with your friends or your children at home, whatever the case might be. Share the video. If you wish to sponsor us, we don't have problem with that. You can just inbox me or you send me an email or just leave your message within the message box. Thanks ever so much. This is my email, pcdjr@yahoo.com. Thanks ever so much and see you in our next lesson.